welcome to day number 4. So, day number 3 we looked at operators, arithmetic and assignment, comparison and logical. Now we're in day number 4 and we are looking at operators again to continue where we ended. We're looking at identity today and membership. We are looking at Bitwise. Let us dive right into our visuals. And we're here. Okay, so this is where we ended the last time. Now we are going to continue from here. So I hope you don't get confused. This is where we ended. I think I'll just create another file and I'll call this operators but 2. Operators 2. Okay, .py. And there we have it. Well, that's pretty awesome. I'm just gonna close all this stuff that I'm not using right now. Well, I'll save this. I didn't save it the last time. Okay, that was pretty annoying. I hate that sound. Okay, now we are doing this today. Now we are looking at identity and membership. What do you understand by identity? Well, I identify as a programmer. Okay, anyway, jokes aside, so identity is pretty much how you can tell that something is this, or how something is pretty much noticed or addressed by. That's pretty much identity. And membership, or are you a part of something or are you not a part of something? Something like a gym membership or a club membership or stuff like that. So today we are looking at membership, and with membership and we're also going to be looking at identity. So membership and identity. So these are the two things we're going to be looking at. Now there's one thing that you need to note and to understand clearly about these two types of operators. One is I'm going to be using strings. It will be a little bit confusing, but you understand clearly with the one I'm going to explain to you. Another thing is later on these will be used the right way. What I mean by that is right now you are not yet to that level of using these efficiently, but they're mostly used on user-defined data types such as strings, tuples, dictionaries, and so on. So in this particular lesson, I'm just going to show you the basic use of these operators. Shall we start? So I am gonna have two things. I'm going to have my name, which I love so much, and I'm just gonna go ahead and type that over there, and I'm going to have occupation, or I can say just job, whatever it is, and I'm gonna say tech. I'm good with that. So after that, I'm now going to do something interesting. So I'll be like change, or I'll be like transfer, and I'm gonna declare this as my variable job. Now you're gonna see why in a few minutes. So let's say in identity or in membership, I think I should start with membership. Okay, let's start with membership. But with membership, I need a sentence. So I can be like slogan. I think this will be fine. Slogan, and I'm gonna say in slogan, I'm gonna say tech with Lottie, and there we have it. So I have my slogan, which will be easier to demonstrate membership. And in here, what I'm gonna do is I'm gonna print something out. So the first thing I'm gonna be testing in membership is the in operator. Okay, so the in operator checks if a string is a part of a given string. Now this might sound a bit confusing. Maybe it's because of the way I've written it, or I can say checks if an entered string is a part of a given string. I think this makes much more sense. So now if I go ahead and print this, and I'll show you what I'm talking about. And if I go like I would say Lottie. So since this is a string, this will be my entered string. Okay, and I'm gonna say in slogan. So if Lottie in slogan, let's see, is it true? Yeah, it is true. Lottie is in slogan. And let's check if Lottie is not in slogan, right? It's gonna return false because Lottie is in slogan. So now I'm gonna say Lottie not in. So this is the not in operator. Checks if an enter string is not a part of the given string. So this will return false because it is a part of the string. So these are the two membership operators that you can use in and not in. So an application of this would be commonly used in manipulation tasks, such as checking for the presence of a substring or a pattern in a text. Pretty much stuff they use in AI. It's pretty cool. For example, when someone is talking to an AI like Hello Siri or stuff like that, Siri actually isolates all the other stuff and just gets Hello Siri and then activates. That is one way you can see how this is actually used. There are way more complex logics behind how Siri works, but that's pretty much the basic understanding and way that it operates. It isolates every other word and then just gets the one that they have specified it should hear. So if I were to create a software and be like Lottie, or I'm just talking something else and like tech with Lotties, it will isolate everything like tech with and then just get the word Lottie and then execute whatever command that I have given it. So that's pretty much how that works. Let's look at identity, right? Identity, pretty much the same thing, is words. In this one, we're going to be using is and is not. So these are the operators, and then I'm going to be going to identity now. This one is the is. Now this one is a bit tricky. So if the contents, okay, are the same, if they're the same, but if the content are the same, if the content are the same but have different memory locations, it will return false. So this is very important for you to understand. So the content must be the same object. That's one condition that has to be fulfilled. It also needs to come from the same location for it to be true, else it will be false. Okay, so is means, okay, the object type should be the same as well as the memory location, else it will return false. So if I go ahead here and clear this out because I just copied and pasted it, and then if I were to say name is job. Now name and job are the same object type or class type, which is string, but they're in different memory locations. So this is gonna give me false. See? However, if I were to use this the same way, but if I were to use transfer over here, the object type is the same. If I use transfer here, the object type is the same, string, string, and also the memory location is the same, because this is the same memory location as where transfer is, because I am giving it the data from this memory location. I hope that makes sense. If I run that, it will give me true. So that's how the is works. Now let's check is not. So is not is pretty much if they are not the same object anyway. So if I go here, and actually I'm gonna copy this because it demonstrates clearly what I want to show you guys. So if I go over here and I say is not, well, of course it's not, because name and job are in different memory locations, so it will give me a true value over here, true. If they're in the same location, it will give me false. For example, if I copy this over here, I'll just copy that over here, and if I put it down here, and if I were to put is not here, it will give me a false value because they are in the same memory location. So false boolean value over there. So this is about the membership and identity. Now let's get down to Bitwise, which is what we're gonna be closing with today. Bitwise, what are Bitwise operators? Bitwise are the things you find like AND operation, you find stuff like OR, you find stuff like XOR, and then you find stuff like NOT. Now, these operators basically have to deal with you understanding binary to a certain degree. Okay? So, I'm gonna try my best to explain this to you so that you understand it very, very well. Okay? This I'm going to try my level best. Okay? Where am I typing? Oh, sorry. I am not typing anything. Okay. Now, what I'm going to do is I'm going to explain these things to you guys in as much detail as possible. Hope it won't take up too much time, because binary is not part of the lesson, but you need to understand binary to understand a little bit about how bitwise operators actually work. Okay? Now, let's say a number 0, right? In memory, or in pretty much binary, this will be represented by 4 zeros. Okay? It will be represented by 4 zeros. Is equal to 4 zeros, right? So if I had a value, right? If I had a value 10, it would be something like, wait, so I'll say number is gonna be equal to 10. Now, if this is my value here, you have to understand that if 0 is equal to 0, 0, 0, 0, then 1 is gonna be equal to 0, 0, 0, 1. Since binary only works with 1 and 0, you can only alternate or change the other number to 1 or 0. That's it. So for me to get 10, I'll go ahead and start switching the 1s and the 0s. So it would be like, if the number is 1, it would be 0, 0, 0, 1. If the number is 2, it would be 0, 0, 0, 1. It would be 0, 0, 1, 0. Then if the number is 3, it would be like that, and it will start, the 1 will keep on moving to show you what number it is. And then if the number is so it will be 0, 0, 0, 1. So let me just put them down here for you guys so that you don't get confused. If it's 1, it's gonna be is equal to, the thing is, you need to learn a little bit of binary. I think I'll just create a full tutorial on that and hope to link it later on after we are done with this series, because you pretty much won't use these until you're doing pretty much advanced stuff, but it's just good to know that they exist and you know a little bit about them. 0, 0, 1. And then if I want to turn this into a 2, then I'm going to have 2 is going to be going to be 0. It's gonna be equal to, I forgot an A U over here. It's gonna be equal to 0, 0, 10. So the one will move from the other one. So the first one will tend to 0, the other one will tend to 1. And pretty much the procedure just keeps on going like this. We'll keep on dealing with the first two values until we run out of them, until we iterate through the ones and zeros completely. So if I want to write 3, it'll be something like this. So it'll be 0, 0, 0. So this will be 1 because I'm iterating through them all over again. And then this will be my 3. So this will be my number 3. And then my number 4 is going to be, let's see, my number 4 will be, since I'm done iterating here, this will be 0, this will be 0, this will be 1. So this will be my 4. And pretty much it just goes on like this, like this. The next one is going to be 0, 1, 0, 1. The next one is going to be 1, 1, 1, 0. The next one will be like 0, 1, 1, 1. Then the next one will be 1000. That's 8. And then the next one will be okay, let's see. 10 will be 1010. Yeah, so 10 will be 10. So I'm just gonna put this 1010. And I'll try to use smaller numbers so that you get to understand. I'm not teaching binary, but I just want you to understand a little bit of how it works. So we'll have a different video on that if you really want to get into understanding how binary works. And this actually, I'm representing it in a 4-bit sequence. You can actually represent it with like 16, 64, 32-bit sequence, depending on whatever it is you are working on. But that's way later after you're done with understanding all this programming stuff. So I'm just gonna go ahead and put my 4 over here. And of course, my 4 in binary is going to be 0, 1, 0, 0. This will be my 4. Yeah. So now you might be wondering, why am I even teaching binary, or why did I even bring it up? Well, to understand bitwise, it's actually very important for you to understand how these actually work. So bitwise is something very close to memory. So if I were to print something out, so this will be my AND operation. So my AND operation, capitals all the way, and this operator is denoted by the AND symbol, which is that little weird looking number 8. And I'm gonna change this to number 2, and I'll put here, so I'll say number and number 2. So what this is going to print out, okay, is 0. Now I need you to understand how this is actually happening, but let's try it out. Maybe I'm wrong. And voila, we have 0. Now let's explain how this is actually happening. So how this works actually, okay, now look at this. This will be the easiest way of me to explain this. Now basically we're talking of 1s and 0s. So what we're trying to look for, the AND operator will work pretty much exactly the way the AND word was working in the comparison operators. So if both these numbers, which are represented in memory like this, if they have places where one corresponds to the other, then we'll count that as 1 bit. But in this particular case, 4 and 10 do not have a place where they are corresponding. But by that I mean, in the place where there is 0 here, there is 0 as well. In the place where there is 1 here, there is 0. In the place where there is 0 here, it's 1. In the place where there is 1, it's 0 here. When you look at this, it clearly shows that there are no places where 1 is corresponding or is the same, like is matching. Because of this, we have to count it as 0. I hope that is making sense. So let's try to get something that might have 1. Let's try to get the number 3, shall we? So I will put 3 over here, and you're gonna see. Can you guess what the answer will be? So our three is represented as this. This is how our 3 is represented. We have a place where 1 is common. Can you try and guess what the answer will be? Of course, you have 2, because 1 and 2 is what we're having a correspondence of the two numbers. So this is pretty much how Bitwise works. So if I had 4 over here, of course it's not gonna give anything, to give 0. If I had 0 there, it would give 0. If I had 1 over there, it would still give 0, because there was no place where the ones were corresponding. I hope that makes a little bit of sense. But yeah, this is how Bitwise actually works. Now, let's move on to the next one. The next one is pretty much the O operator, right? And with this one, I'm just gonna go ahead and copy all that, and I'll put this down. So the O operator is represented by this. If you can't find that, it is the key that is usually alongside the backslash, not the forward slash, but the backslash. It's a long line. So this is our O operator. So what does O mean? What does it do? And how is this? What answer am I gonna get from here? So if I look at this, I should get 14 or something. 13? No, I should get 14 definitely. Let's see. If I run this, yeah, I'm getting 14. So again, how is this working? So like, just like O in the other one, so it doesn't matter which one it is, like which numbers are corresponding or what. So long as on the other side there is a 1, and then on the other side there is a 0, it's pretty much like the 1 in the operators of O. So if the number is, okay, so here we have 0, 0, here we have 1, 0, here we have 0, 1, here we have 1, 0. So it doesn't matter, this will be counted, this will be counted, this will be counted as well, okay? So in this example that we are giving, right, if I were to add these up, I would get something like, 1, because there's 1 there, and then 1 because there's 1 down there, and then I'll get 1 again, and then 0. So this is 0, 0, 1, 1, 1, 1. So this is what I'll get. And if you follow this formula, the answer that I'm gonna get is this, which will be in turn the depiction of the number 14. I hope that is making sense. Don't worry, you can keep on moving with it. Our next one is the not. So our next one is the not. I didn't want this to take long, but if it's something you want to get into, I can make a separate video for it, and then you can understand about how these actually work. Alright? So this is this little squiggly negative sign or whatever it is. So this one actually works just with one number. So I'm just gonna use let me use number 1. 10 is easier to work with because it's easier to calculate in the head as well. I'm not perfect at binary, but I would definitely try to explain to you what I understand and how it actually works. Okay, so the not is a bit, it's more like dealing with just negative numbers. So I'll explain to you how this works and how you can actually understand it much better. So what it does is it simply just it changes every aspect of it, pretty much inverses the number. So if this, let me clear this out. If this was like that, what's gonna be now after performing that will be 0101, which gives us a different number. So if it gives us that, which in turn, let's see if I swap these. So since it's inversing, this will be a negative number. So this will give me 11. So which will be negative 11, if I'm not mistaken. Let me check. I'm not mistaken. Yeah, it'll give me negative 11. So pretty much that's how it works. And I'm already on 25 minutes. So I'll try to wrap it up as soon as possible. Let's do the last one, which is the ZOR. Copy, and I'm gonna paste that ZOR, which is over here. And trust me, you pretty much won't use this until like a long time. So the ZOR operator will be this little thing over here, and I'm gonna go back to using my two numbers. So I'll say number, and I'll put that over there, and I'll say number 2, right? Yeah, and I have that over there. So I think now what does the ZOR operator actually do? The ZOR is very much similar to the OR, but I'll try to explain the difference. Okay, this is like how can I say? What it would do is it will switch on, like it will turn 1 to 1 and the other one will be turned to 0. Like it will literally just inverse one of the numbers, okay, to become ones or to become the other bit. I don't know if that makes sense. Take for example, you have two light switches, two light switches, yeah, and you are saying I'll only turn on if one switch is up, and I'll turn the other one. So like the lights will only turn on if one switch is up and the other switch is down. It's like an either or situation. So either one switch is up and the other is down, or both switches are up. I don't know if that makes sense. So if like you're eating if you're eating something like a bowl of soup or noodles, whatever it is, and you find that you don't want it, you don't want it hot, like you don't want like, how can I say, like you don't want it too hot and you don't want it cold at the same time. I don't know if that makes sense. It's really complicated to explain this, but just know that if one switch is on, the other one has to be down. So it's an either or situation. That's how the ZOR works. So in this particular scenario, again, we're gonna end up with the same value, which will be 1110. So I'm gonna clear this. So if you can see this, here we have either one of them is on, that's fine. So one is off, one is on, that's how it should be, 1. One is off, one is on, that's how it should be, 1. One is off, one is on, that's how it should be, 1. And we're gonna get the same answer, which is number 14. Okay, I think that's about it, and I think I'll see you guys in the next one. So don't worry about this. You are not definitely gonna use this anytime soon, but I just thought to give you an understanding of how Bitwise operators work, because I've seen most tutorials don't actually get to teach them. So have a good one, and I'll see you in the next one.